In this procedure, we're going to actually be using a 0 to 10 volt signal. We're currently moving away from those, but we still have some older processors and cards, and they're still using 0 to 10 volts, so you will run across that. So we're going to use a single phase voltage transducer from Ohio Semiconductors that has a range of 0 to 600 VAC and outputs a 0 to 10 volt VDC signal. I have 120 power supply, because you have to have power on this. You have to have a minimum voltage or this thing would even show a signal. So I'm going to have to power it up to get a signal out of it, and we're just going to use line voltage in my office, which is 120. So let's look at our instructions here, and we'll begin. We've determined what it is. We're going to look at our calibration sheet, which I believe is right here's a screenshot of that. So at 600 VAC, it said they run through the calibration and they had a min and max as found and as left. That's where they left it. So 9.989 volts should equal 600 VAC in our scaling. And then, of course, 0 equals 0 volts. So I've already done this. We've placed the min and max values from our calibration sheet in there. With no voltage to the transducer, place the raw present input value. I was floating at 0.001 volts, so it doesn't matter. We're just going to move that in there because that's we don't care what that signal is if it's within reason. If it's 0.001 off, it's just that's going to be our low. If I was showing like 1,000 there, then something's wrong with the card and it needs changed. So the scale for control logics is 0 to 10,000, and engineering units is 0 to 10 VDC. Most importantly, you're going to have to remove the signal wires from the sensor, because especially with voltage, if you have anything else hooked up, you're going to load it. In my example, you can leave the ground hooked up, but you got to get the positive off. It cannot be hooked up when you hook up your process meter, because if it is, you're going to draw the whole circuit down and you won't have a correct calibration. So we're going to inject a high side of 9.98 on my little clamshell transducer as soon as I get that up. There we go. Power button. We're going to hit the mode to source. And I don't want to, so you have to hit the up and down and scroll through everything. I'm just going to hit the memory button, get myself to 10 volts, and then I'm going to back it down. That's a little bit easier. So now I'm simulating 9.98 volts. When you use this process meter, make sure that you have this voltage selector switch set correctly. Now that I'm injecting the correct high signal, I'm going to go back to my calibration application. We can see what we got here. So it says that my present raw input is 9.989 or 87 volts, which is what I'm injecting in there. And so 88, 90, you're never going to get exact. It's always going to float a little bit. But we're pretty close. So I'm going to take this number here and I'm going to type it in over there. That becomes our max. We already set the scaled min and max earlier from our spec sheet. So now that we've set that, we should be reading 600 volts. So now I'm going to disconnect the power and hook it back up. Take my little jumper off. We're through with our process meter at this point. If we have issues, take it off. This is just for demo. Use crimps on these. Not appropriate to shove a wire underneath there, but this is just for demonstration. So we're going to hook this up. And now I'll be honest with you, some of these Ohio sensors have quite a bit of bleed off, millivolt bleed off. This one is powered, so if there's no power, there shouldn't be any bleed off because the electronic circuitry is not powered up. So we're going to go see what our signal is. Right there. So we'll see that, yep, we're still floating at 1, so our car is just a tiny bit out of whack. So our present raw input is 1. Everything looks good. It's floating just a tiny bit. That's fine. So it says 0. All right. So now I'm going to power it up, and I should read around 120 volts. And that looks pretty good. So I would take my electrical meter and I would verify this signal here by placing my meter directly on here and make sure that it is whatever the ring tolerance is. And I'll be honest with you, it's at 1%, which is pretty tight. So if you're having trouble with that, you need to inform me so I can get with the QA office and have that up. Because I don't think that's going to work, but we had to put something in the documentation. So go to your tolerance section and see what your min and max. That's min and max, plus or minus 1%. So so you would take 1% of what that says, which is 117. So we'll take 117 volts times 0.01 for 1%. That means I can have a plus or minus at that voltage range. So I can have 118.17, or I can have 116, whatever. But you'd subtract. You would add for this for the high side, and then you would subtract for the low side from 117, and that's what your voltage should read on your electrical meter. Now, I would caution you that you need to have an electrical meter that is in spec, a good working fluke. You can check those out of the QA office. They have a set that they're pretty good. So if you're having trouble with that. Update your gauge ID number and the serial number. I'm not going to do it here because this isn't a real, but you would put this in here and take your certificate of calibration and turn it into the QA office with a little note on it that says where you installed it.